Alrighty, ladies and gentlemen, we're on station 3 now, functions and slope. So the first set of questions asks, is the relation a function? So the first one, they give us a graph and they say, hey, is this a function? Well, what we're going to do here is called the vertical line test. We're going to see if I draw a vertical line, does this vertical line ever cross the relation that they gave us twice? And if I look right here and right here, it looks to me like that vertical line is going to cross that relation twice, which means an x maps to two different y's, so this is not a function. First one is not a function. This second problem, they give us a table and they say, is this relation a function? Well, it looks to me that 3 repeats, so 3 maps to 10 and to -4, so this is also not a function. You're not allowed to have any x's that go to two different y's, have two different y values. Number 3, we're going to do the vertical line test again, and if I take this vertical line and I draw it, is it ever going to cross the relation twice? Nope, 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 nope. Looks good to me. Never crosses a relation twice, so this is a function. Yes, this is a function because it passes the vertical line test. For the second part here, it says, write the domain and range for number 2. So the domain is the set of x values. But when you list this, we're going to use set notation. We're going to say this is the set of 3, -5, 2, and 3. But you don't list the repeats. So if I put them in order, it'd be -5, 2, and 3. You do not list repeats when you're listing the domain and range. So for the range, I'm going to list here. I'm going to say -4, 1, 4, and 10. I don't have any repeats, but so I have slightly different. I have 3 here and 4 here, and that's part of the reason this is not a function. So domain is your x values, range is your set of y values. Complete the table of input, output. So let's see, if they give me an x, I'm going to go ahead and plug that in. So -3 times 1 plus 2, that's going to give you -1. If I plug in 2, -3 times 2 plus 3, -6 plus 3, or plus 2, I'm sorry, that's a 2. -6 plus 2 is going to give you -4. Now when they give you the output, you got to go the other way. So what I'm going to do is write a little equation. I'm going to say they gave me the f of x. So I'm going to say 14 equals -3x plus 2. And I'm going to solve that. So subtract 2 on both sides. 12 equals -3x. And then if you divide, you're going to get -4. So if I plugged in -4, I would get 14. I'm going to do the same thing with 21. I'm going to say you're giving me an f of x, an output, so I'm going to plug that in and figure out what I would have to plug in to get -21. Now let's look to this. 19 equals -3x, so when you divide both sides by -3, you're going to get -6 1/3, or -6.3 repeating as a decimal. The last section says find the function rule. Probably the easiest thing to do is find your change in y over change in x. So I'm counting by ones. Whoa, that's cool. I'm counting by ones here, +1, +1, +1. My y's, I'm getting smaller, so that's -3, -3, -3. So the change in y over change in x, change in y over change in x is -3 over 1. That's my slope. So I know it's y equals -3x. I just need to find the y-intercept. And to do that, I'm going to just continue this pattern and say it looks like if I went up to 0, I would have -3x plus 0. So the y-intercept is 0 for that. I'm going to do the same thing here. Looks like I'm getting bigger, adding 4, adding 4, adding 4 as I get bigger here. So change in y over change in x here is 4 over 1, so 4 over 1 is my slope. Y equals 4x. Remember, it's y equals mx plus b. Plus the y-intercept. They gave me the y-intercept. It's 0, 0, so 4x plus 0 again. For the last one, if you look and you see that you're looking for a common difference. This is -48. This is -16. This is +16, and this is +48. Well, there's not a common difference. That means that this is not linear. And you might notice that 4 squared is 16 and 8 squared is 64. This is y equals x squared is your function. So y equals x squared. And that's it for all of our function work.